So today we're gonna explore Webots. Webots is basically like a simulation where you can do robots and do fun stuff with it. Anything, you can build it even from scratch. You can use robots that are already there. You can just select it from a menu and it will be there. And you can just use the functionalities. And we're gonna try both actually today. We're gonna build our own robot and we're gonna use an existing robot and add things to it. So one thing to just mention, this is the Webots guide. It is very helpful in case you want to know more about Webots. It has like everything you need to know, all the functions, everything that you, for example, if you want to access something in a robot, like a parameter or something you don't understand, you can just search it on this guide or even on Google and just right next to it, Webots, the documentation should appear. Another good resource is this one. Maybe I can send the link. If you want, you can send the link to the participants at the end. Just like a resource. Or if you want, you can just write Webots tutorial by Kajal Gada. She's... Yeah, sure. Okay, sure. So this is very helpful. Actually, our robot is going to look very similar to this. The robot that we're going to build from scratch. So this is very helpful in case you want to explore more different things about Webots. I would like you to scan this QR code. Where is it? This will contain the code that we're going to use today. So let me now go to the Webots itself. Let me show you, first of all, the things that we're going to do today. So, for example, here's our robot that we can create, or we're going to create today. Wait, sorry. I'm just moving him away from the light. There's a light that I added. Is it visible? Yeah. So the robot, based on this light point, it should do different actions. For example, if I run it now, if I say this. Okay, it's kind of slow, but as you can see, it is kind of approaching the light. Okay, wait, maybe this is not the best example. 1 second. You can see it is going towards the light. And we're going to learn how to do that. And then once it approaches the light, it speeds up. The other thing we're going to do today is this one. Okay. So let me just put in a starting. So the robot has a camera, a pen, and obstacle avoidance. So the robot is gonna, if it detects a green object, it's gonna print green color detected and so on. And if it approaches an obstacle, it's gonna go and approach it and then go back, rotate a bit, and then keep on doing that until it avoids the object. So if we try running this. Okay, it did not go back a lot. But as you can see, it detects, okay, it's because it's moving so fast, that's why we cannot see it. But let me make it go a bit slow. You can see it should go back a bit. And then rotate, go back, rotate, go back. This is like a basic obstacle avoidance algorithm. If you detect something, just go back and rotate. And the reason why it slides at the end is because of the like the sensor is not, like I'm using the wrong sensor. I'm not using all the sensors. Actually, in today's implementation, we're gonna like do it in all the sensors, so that even if it detects on the side, it should also go back and rotate. And as you can see, it was also printing detected color because we have a camera, and the camera detects a green object, it's gonna print color green. So that's what we're going to do today.